Hi everyone, thanks a lot for coming to my talk. So yeah, I'm Ollie Bown, now at University of New South Wales. I'll start by introducing myself with a bit of musical background because it's probably worth explaining myself, not having a formal music background, and also explaining why I was in a faculty of architecture, I'm now in a faculty of art and design, and I'm giving a talk about music. Here's a very young me. I started out with a keen interest in electronic music, but without any anyone telling me I should be getting a formal music training or anything. This is a concert from around, well, I would think I was around 25, performing with a laptop. We like to explore the affordances of performing with laptops, so we, in this particular case, took the opportunity. We had a friend who was a car locksmith, and he told us he could easily get us a vintage car to do a gig in, so we took him up on that. We didn't ask any questions about how he got the car. Basically the entirety of my work and interest in music production has been very much centered around this particular piece of technology. This was my first laptop, and when I first played with it in around 96, 97, myself and my cousin, the other half of the duo that you just saw, we'd never seen anyone doing this. This is just the technology that we had acquired, and we went around performing with laptops. So we really didn't have any precedent for what it was we were doing and how people were doing it. And all of the cliches were true. People asked you whether you were checking your email when you were performing. People thought maybe they weren't sure whether you were DJing or performing, so they'd come and request Madonna when you were playing, and so on. But I'm not really going to be talking about the performance aspect of laptop music, although I've got lots of interesting issues that I'm keen to explore and conversations I'd like to have. But more about the nature of the computer and the way that computers are transforming the way that we think about creative practice, and particularly composition and performance. So this is what we did. We performed with laptops, but we were, so I just want to get my notes, presenter notes, there we go. Whoops. Yeah, and through this practice, started to explore questions about what this thing was, what kind of affordances it had for musical performance, and so on. I was at a talk at the Conservatorium 1 or 2 years ago by Lieven Bartels, the director of the Sydney Festival, and he was giving a very interesting talk about how the kind of 20th century history of art music and experimental music, people like Pierre Schaeffer and John Cage and so on, how these fed into a whole load of contemporary music directions such as hip-hop, techno and so on. And I was quite interested because my personal experience of that progression was actually that those things emerged out of the affordances of the technology, not through a direct lineage of input and inspiration from those fields, but that then there was a kind of enlightenment, like a realization that there was a wider intellectual process that kind of converged. So I think around the middle of the last decade, there was a great deal of convergence between an alternative music practice and a more established one, where there was a lot of kind of realization of the intersect. And we now live in an age where there's a much happier marriage between those fields, and I think that's exemplified by the new contemporary music degree that the Con is putting on, which I think is a great initiative. So my interest in computer music and laptop music rapidly progressed from using tools to realizing that, I mean, as soon as you're working with software, it's a very slippery slope to trying to make your own software. And we have, we tend to still divide up the world of software between the people that make it and the people that use it. But in fact, we have a much more complex ecosystem now, and I'm sure anyone who's worked in composition for any amount of time using software will have come across something like this tool, Max MSP, which is a creative environment. Excuse me, shouldn't have taken fizzy water. creative environment whereby you can make your own software, but you're doing it in a very end-user friendly way. You're patching cables together. Sometimes what you're doing looks a bit like a studio, and you're just wiring bits of studio technology together. Sometimes those bits of studio technology are plus symbols and divide symbols, and you're actually making algorithms. So there's this very fluid connection. And one of the things that in my theoretical work leading into what I'm about to be talking about, musical metacreation, it's the automation of aspects of the creative process, is how, as you step into this world of software, you tear apart quite traditional boundaries. So, for example, in the world that I was working in as a laptop performer, there was a lot of affirmation that this thing, the laptop, should be treated seriously, and one way people expressed that was, this thing is an instrument, it's just like any other instrument. And that never really rang true to me, because it's really not like any other instrument. It's a general purpose computing device. So to say it's like an instrument is just a simplification, really. It certainly can be configured so that it behaves like an instrument very easily. If you turn the keys on the keyboard into triggers for sounds to play, then you're somewhere towards an instrument. But of course you can do all other kinds of things. And in a paper that I wrote in 2009, where I was really felt able to kind of develop a more kind of clearer picture of what I think we're doing with software, we questioned these kind of traditional categories and showed how software can kind of drift quite seamlessly between categories, such as a piece of, or a composition, maybe a dynamic composition, or maybe something that embodies musical structure in that sense. It can have the qualities of a performer, so it's certainly performative in the sense that that software acts and behaves and can respond and can initiate actions. And so we end up with this kind of soup of these categories, and we end up pieces of software falling amongst all of those. So a concept that I developed with colleagues is the idea that within software you have things called behavioral objects. They're objects just like the physical world that we construct, but their core raison d'etre, their existence is about behavior. They're behavioral, fundamentally behavioral. And it's the interaction between those objects that we need. So we still don't, I think, have a clear theoretical frame for thinking about what they are, how interaction between pieces of software and humans leads to certain outcomes. So that's just something I'm just laying down a couple of thoughts before kind of launching into the two main areas I want to talk about, and we can come back to that later on. So a nice way of thinking about software and this kind of fluidity between programming and being a user of software comes from Robert Plotkin, whose book The Genie in the Machine talks about a potential future of automated creativity, which is one of the areas that I'll be talking about. So Robert Plotkin is actually quite interested in the kind of legal dimensions of that, the questions of authorship and so on. And he makes this kind of very nice, uses this very nice way, I think, of describing what it is that we're doing with a computer. It's quite poetic, but he's saying that he's talking about automated creative systems, and he's saying they're a bit like genies. If we can find the way to express in the correct terms the wishes that we have, they will realize those wishes. So he's talking about a near future where we can specify goals, outcomes. In computational terms, that might be some kind of aesthetic qualities. If we knew how to express those, these systems will discover offerings, that satisfy those requirements, and that might apply to designs and so on. So you state a wish, and the genie grants a wish. And what Plotkin points out is that actually we're on a kind of smooth continuum of evolution of these types of systems. So programming languages are just the latest way we have to tell a machine our wishes, and currently they're still very much in the sense that you have to tell them one by one, line by line, what that wish is. But in fact, if you go back in time, you had assembly languages and they were even more cumbersome, and when people discovered compilers, or people invented compilers that allowed us to use higher level languages, that took us a step closer to this being able to kind of realize goals. So,
could you use the mic? It's terribly hard to hear you.
Yeah, sorry.
Excellent.
Is that on? Yep. Okay. So I hope everyone heard most of what I just said. We're currently in an era where there's a kind of flourishing of languages, creative programming languages, and so on. One example of which is actually the fact that people there's an emerging practice which is extremely interesting to follow, of live coding, where people are actually doing live music performance with dedicated programming languages that they've developed for efficiency of musical expression. This image doesn't really give you enough resolution to see what's going on here, but even if you could, you might not follow the syntax of this particular language, but you can look online at videos of people live coding, so composing music in real time. So those are just some kind of current contextual issues before leading into the two main areas. So firstly, I'm going to talk about musical metacreation, which simply defined is the automation of any part of the musical creative process. So this is an academic field that sits amongst a wider field of the automation of any part of any creative process: art, poetry, design, science, problem solving, and so on. So we call ourselves in that community Computational Creativity, and we're interested in these fundamental questions of automating creation. So is that viable? Is that something we can do? Some of the most inspiring examples that affirm that this is an area that's fruitful and happening now are, for me, from the field of artificial evolution, where you set target behaviors that you want some piece of software to exhibit, and through a process of search and optimization, that software will discover ways to achieve those behaviors. It's a very famous piece of work by someone who's an artist and scientist, Carl Sims, was to evolve these virtual creatures in a virtual 3D environment, and simply to specify things which are very similar to what you might actually find in nature, in biological evolution. So, for example, how far can one of these creatures travel in a given amount of time? And this is entirely grounded in a virtual physics, so there's no cheating going on. These are creatures that swim through virtual fluids or walk across virtual surfaces, and very effectively manage to evolve these snake-like behaviors, snake-like body structures and behaviors, and so on. So you can watch videos of this, and it's extremely compelling, thinking, okay, these look lifelike, these look like biological forms, and they've emerged entirely from this process of evolution. So just specifying goals and letting evolution do the search. And this has been used in very practical cases. This is an antenna that was evolved for its efficiency at the task it performs for a satellite, and the structure of this antenna was evolved using artificial evolution, and it's been analysed, and people understand why it looks the way it looks, but they didn't know that before they'd done the evolutionary search. This was a discovery by evolution. So there is this kind of clear evidence to say that we can automate the process of discovery. So evolution is one area. Another area which is having a lot of traction is machine learning, and this is something that if anyone's a regular Facebook addict, they will probably have seen these such images, which are really quite eerie, weird image recognition algorithms that have been fed back on themselves. So they've learnt to recognize structures in images, and they've actually what they've done is they've fed back the machine learning so that it modifies the image to better resemble the structures they're expecting to recognize. And through this process of iteration, basically the machine does something that we might describe as dreaming, or kind of daydreaming or imagining. So it starts to see faces in clouds and so on, and you can run these. So in fact, they made this software available, and people have been having a great deal of fun making machines that imagine. So again, we can see clear potential there. We can also tear this to pieces and say it's nowhere near human creative capacities and so on. But we'd be shooting ourselves in the foot, I think, just to kind of say that there's nothing here worth exploring and so on. So in a slightly more technical version of this talk, I would go through some of the techniques that are used in musical metacreation. I've already basically summarized two of the key methods. So one of them is search and optimization, where you just define a target, and the other is learning. So in music machine learning, you have systems that are fed a large corpus of musical history, and they learn the structure, and then they might be able to be fed back on themselves to regenerate things in that style. So we have a notion of style learning. Or we might have an evolutionary approach where we set goals and things learn to achieve those goals. So just a really kind of wide sweeping history. The kind of first thinking in this area really came about through cybernetics and the cybernetic movement. That rapidly fed into artistic practice. So, for example, in the cybernetic serendipity exhibition in the late 60s in the ICA in London, lots of exciting kind of new thinking about art as system, as kind of interactive performative systems emerged, and this has really been the heritage that we still have today of people approaching computationally creative art and music. But we've been through several other eras. Particularly in musical metacreation, we've got projects such as George Lewis's Voyager, which is over 20 years old and is a different kind of system from the two I just described. It's a rule-based system. It's basically the expert knowledge of George Lewis, who's a great trombonist and jazz musician, kind of just embodied in this piece of software that he's built over a very long period of time. And it's an extremely successful system. We just demonstrated it in Vancouver, and 20 years on, it's still incredibly successful at creating an engaging interaction. And I've kind of summarized these kind of eras at the bottom here. So we've kind of come through an era of personal computation where individuals are building systems that are kind of tractable for one person to make and work with. And we're clearly entering an era of big data where people are working on much larger scales. And the real holy grail there is to find the ways that you can make a system that scales up successfully, so that you can really make use of the massive body of knowledge that's stored in various forms on the internet that you can learn from or target. So I'll be talking a bit about that. So I should actually show what I do in this area, and it's very much performance based, and it's very much based around establishing a sense of interaction and an interactive experience that the musician can engage in and that the audience can perceive, which is not very helpful because I don't have video. I'm just going to play a short piece of audio here. So just a short clip of a performance. My system, which is called Zamutin, performing with Francois Huel, a clarinet player based in Vancouver. You can find a full video of that on Vimeo. And I mean, just some of the thinking behind what kinds of interaction is of interest here. I tend to think in a kind of sub music theoretic level, if you like, kind of sub note level, and just think about very basic forms of interaction. I take an approach inspired by artificial life and simple agent behaviors, and drawing from kind of other people's writing in this area at the kind of primitive level of interaction. Think of 4 categories of interactive forms. So shadowing is one in which a performer would be matching as in a sort of rhythmically matching and performing alongside another. Mirroring would be one in which the performer is looking to kind of reflect the style of another performer. Coupling is one in which 2 performing systems are coupled in some way which is not literal and necessarily clearly perceivable, but can be measured in some way, so you can understand that there are forms of interaction, but they're not so literal and they're not so easily identified. And negotiation would be a slightly higher kind of cognitive approach, whereby the individuals are actually aware of the musical content. They're aware of musical goals, they have musical goals, and they might be aware of each other's musical goals, and so they're actually doing performing a sort of theory of mind based activity there. This is all in the context of performance, and of course musical creation doesn't entirely happen in the context of performance, so you can think of the agency that we're interested in here as being something that could be performative, or it could be kind of super beyond the scale of a performance over a larger time scale, as in the activity of a composer working to create musical content, which I would refer to as mimetic, drawing on the notion of the meme, the kind of proposed unit of culture. Although I'm not a huge fan of this particular theoretical body, it's a useful word to attach oneself to. So we classify different types of musical metacreation according to these areas of these scales. And so just to clarify that the work in performance musical metacreation has a very different set of concerns. It's about co-creation. It's about the engagement between a machine and a person at the time of performance. And there's quite different concerns when you're looking at that mimetic scale. So a topic that comes up frequently, a way of thinking about these challenges of automating creative tasks is to refer to Turing's test, Alan Turing's famous test, where he basically sets the simple task of asking somebody to try and decipher whether a system hidden behind a screen available through type is a computer or a human. And Turing's test is kind of widely recognized as being relevant and important in understanding AI. The question is whether it is, or how it's relevant and important in the context of creative practice. And just to give you one example, this is quite a typical thing that you might come across, especially when you're reading mainstream journalism, where you come across something about machines being creative. So a claim is being made that such and such a system has written music that cannot be differentiated by music written by a human being. And this is kind of alluding to Turing's test, that that question of whether we can distinguish the origin of the music is a valid question, and that's from a BBC interview. And there's a kind of emerging consensus. I think it's fair to say that there is a kind of consensus emerging around this, that that's deeply problematic in terms of the application of a test that was developed for a certain context to another. Essentially, that boils down to the suggestion that this test is too easy, and it's particularly easy because you, in the presentation of a piece of music, for example, the one I just played, where you could clearly tell what the software was versus the clarinetist. You don't know what I've done behind the scenes, what's in the background. So this is a very problematic test in that respect. More generally, for thinking about research, as opposed to, say, thinking about engaging the public in the development of the field, this is a really impoverished form of study. It might tell us that we've achieved this one target, but it doesn't give us any of the detail regarding what that means. So I would say it's impoverished. I would say that anyone conducting research in this area doesn't actually gain a great deal from conducting that kind of test, given particularly that it's kind of a very easy one to in a trivial manner achieve. So we constantly have claims that these systems do perform to a human standard, but we have always with those claims the kind of question of how we then unpack who did what the influence of the programmer is, what the frame is of that system, what it knows, what it was programmed to do. It could even be, if it's a learning system in the extreme, it might learn so well, it's known as overfitting, that it basically just plagiarizes and reproduces a piece of music. If you'd never heard that piece of music before, technically you've got a learning system. It's reproducing something that's a reconstitution of its source material. It just happens to have done it far too accurately, and we would call that plagiarism, but we don't always have the means to know that that's what it is. And to complicate matters further, it's important, and I'm sure that there are ethnomusicologists and musicologists in the room, to remind ourselves what music is, or in fact to remind ourselves that there's a hell of a lot to understanding what music is. It's not a straightforward engineering problem. For example, I particularly love this piece of research by Newman and Bloom, where they looked at the way that people value things, and they looked at the possessions of celebrities such as Barack Obama and George Clooney, and they saw that people highly value those possessions, and they value them even more when they've not been sterilized or cleaned. In other words, if you gave someone the T-shirt of George Clooney, they would value it more if that hadn't been cleaned. Kind of just reminds us how fickle we are, and also kind of shines a light on. This is actually a paper about authenticity and the value of authenticity in artworks. So this is the provisional but preliminary studies, and that lead on to similar studies in the context of art value. And that's just to remind the computational creativity community in particular that there's a huge amount of framing in terms of understanding how we give value to artworks, and so there's a momentous task in working out how to approach these kinds of questions from a kind of solid empirical grounding. So my interest in recent years in this field has actually been to blow apart the whole question of the kind of attention-grabbing question of, have we managed to make creative machines or not? To take a slightly more maybe Latourian point of view and just assume that we are, our machines are always kind of in some way involved in creative processes and having influence, and just to stop worrying about that kind of problem, and to really think about the questions, the finer detail, the questions of what kinds of interaction we create, how those are made effective, how kind of human-machine interaction leads to different types of creative process and so on. So what I'm really saying is that in the field, I think some of the most interesting work in this area is about interfaces and about the design of interactions and about the more detailed study of interactions. So just a few examples. Andrew Sorensen and Andrew Bown, who do much interesting work in this area. This is an example of a work where they're building a basic interface for being able to automate the composition of music to a film. This is actually a freeze frame from a film here, and this is a timeline that's being mapped over it. And they're looking at kind of affective qualities of the music that you can draw yourself over the timeline of the film, and then they've got a generative music system that is achieving those affective goals in the music that it's generating. Something that I've worked on is systems for quite a simple task, really, just parameterizing music composition so that you can create music for different contexts, which I'll talk about in a second. This is a very simple way of representing a set of musical states in a simple map, two-dimensional map space. So you basically go about pulling apart a composition into states that you consider important in that composition, and laying them out in some way in a two-dimensional space, and then building trajectories through that space. So this is as a compositional tool, where the output is not going to be a single linear piece of music, but multiple variations of a musical structure. Others have looked at the kind of machine learning I just talked about, and looked at interface design for these systems. So this is a way to represent a Markov model, which is just simply a model of the probability of transitions from one note to the next in a musical sequence, but in such a way that someone could actually manually navigate that space. So where the center of this is the note that they're on, or the chord that they're on at the moment, and the elements around the edge show you different potential directions with weightings according to how probable that those next chords are in the existing corpus of music that it's been trained on. So, for example, you could therefore make any choice of chord to go to, but your interface guides you in terms of how you might navigate to the next chord. So that could be a tool that would be used for people learning music, or non-musicians. It's kind of my favorite but also most hated application area, is tools to make non-musicians better at making music, which I don't know what people think about that here, but it comes up a lot as an application domain, possibly by people who don't necessarily who want a kind of rationale for doing generative music, which is fair enough. Here's another interface which actually is interesting because it had a degree of commercial success. If anyone ever owned a Clavier Nord Modular G2, which is a programmable, software programmable synthesizer, this was an evolutionary algorithm, evolutionary interactive system for being able to evolve the sounds of that synthesizer. So forget about presets and forget about actually turning the knobs individually. You could just listen to sounds and say which ones you liked, and through a process of iterative selection, find your way to interesting new sounds. And I'm very impressed by the fact that this actually made it into a commercial piece of software, because that actually hasn't, so maybe it's not an impressive thing, maybe it's a failure. It hasn't actually really caught on as a practice, and yet it's still considered a very, conceptually at least, an approach which has a lot of potential, that we could perform this kind of search. I'll be talking about that a tiny bit more in a second. And we have approaches that are driven by machine, music analysis expertise. So this is, this is just a score. There is a great online video that I highly recommend if you search for flow machines and the Flow Machines project. Francois Pache has been doing really interesting work extracting rules of style and then applying those to existing melodies. So this is Giant Steps, harmonized in the style of Wagner, and he's got many other examples. He's got, I think it's Ode to Joy, and then he's done the accompaniment to that in about 15 different styles, which is fascinating to check out. And it's all been done automatically. So extraction of style, application to the melody. And so you've got these wonderful kind of recombinatoric tools that are part automated, but how you actually use those and apply those are still up to you. So all of these are really examples of how we take this technology, and this is not at all about fully fledged autonomous machines. It's about interfaces that give us access to the kind of intelligence and power of these systems. So I said I'd talk a tiny bit more about interactive evolutionary search. This is obviously an image-based example, but it's one of the interesting areas that I think is worth paying a lot of attention to at this stage in our research development. This is work by Ken Stanley and his colleagues at University of Central Florida. And this is just it's kind of a well-known process. Again, it's an interactive genetic algorithm. So you are presented with a grid of images, and you can choose whichever one you want to select. You're basically playing God, and that image will be bred and will mutate and produce lots of offspring, which you can then go and select one of those offspring and iterate and iterate. What Stanley and co have recently begun to look at, which is really interesting, is actually the fact that we don't, when people embark on this kind of search, they don't do so in a directed manner. They don't tend to approach this with a question of what they want to achieve. they just play. And so they've started to find it quite interesting to set this up as again a lab looking at human-computer creative interaction. And rather than saying we've got a great idea for how people are going to discover new forms, they're actually considering this a kind of lab for experimentation. And their view actually is that now the place to look is actually for completely undirected search in creative tasks. And there's obviously a lot of rationale for thinking about it that way. So I've talked much more about musical metacreation than I will about media multiplicities, but that's fine. That's probably the larger area of my interest. What I want to add, in addition to all of that kind of sweeping overview of methods and interaction, is the fact that we're kind of on a constantly shifting ground with respect to what we're doing, because this is me again performing with another instrumentalist. This is a constantly shifting genre, so we go out and we perform these kinds of shows, and we start to get interested in different questions around what we're doing in that performance. So we've given up imitating free improvisation, and we've started to think of our own questions, and these things feed back on themselves. So we're starting to see these kind of genres of practice emerging out of this kind of software autonomy and so on. And this has some really interesting spin-offs. A colleague of mine, Ben Hogue, works with a chef to create food opera, where he's got an adaptive dynamic composition that has been carefully composed to work with the menu of a dining experience, and also to work as a chorus of voices. So you'll get served your food and all of the music playing, and this is all interacting in some kind of coordinated manner, and he's using adaptive techniques to achieve that. This is an artwork by Daniel Jones and Peter Gregson, where they're taking some kind of Twitter stream of mood in the UK, and they're converting that into a constantly remixed piece of music. This is a wacky project by Volkswagen and the band Underworld, where they're doing a similar thing, but it's the driver's movements in the car, and the speed of the car and the direction of the car is all feeding into the music that you're hearing on the stereo. You know, weird, unusual kind of rethinking of where music might be deployed and how it might be deployed in an adaptive, interactive way. This is a project by myself and my cousin, who I showed you at the beginning, and we produced this parametric piece of music where we took a standard tool like Ableton Live, and we added a dial that enabled us to flick between 1,000 different versions of a composition and map this dial to different parametric controls. So, sorry, I'm doing these very quickly because I'm going too slow, and it's probably because I'm jet lagged. So just a quick, I've not got very long now to talk about the other side of my work, but this is the kind of segue here. This was a work that I was involved in with Miriam Young, who was at the Sydney Conservatorium a short while ago, and other colleagues at the Design Lab at Vivid 2013. And again, the segue here is that it's using dynamic generative music in the context of an interactive experience where people are being tracked and followed by lights in a space, and that's influencing the music and so on. But it's also in a kind of very site-specific context. In this case, it's right in front of the AMP building on Circular Quay, and all of these interactions are feeding into this artwork that runs all the way up the side of the building using lasers, and does kind of turns itself into the logo of the Amplify Festival, which was what sponsored the event. So this is my segue into talking about music composition in very diverse and different technological environments. That's in the context of massive scale, big building and so on. But my other interest is in the context of what we now call the Internet of Things, the world of networked multiplicitous devices. So everyone's phone in their pockets is part of that network already, and your house is increasingly kind of falling in line with that vision of the future. So this is a project called the Siftio Cubes, which is a kind of game learning experience where these cubes each have a screen on, and you can interact with them and they interact with each other. And you have what is clearly a completely different tangible experience, but still digitally grounded. So we don't, you know, we're looking at a future where we're not just interacting with screens and mice and so on, but we're actually dealing with massive networks of physical objects. So they talk about sensor network systems. So this is each one of these things can sense and it can communicate to the mothership, and so we have a network of sensors. We have examples like this. This is the Spaxels project, which is a load of drones that you can send off into the sky, and they'll actually perform some kind of coordinated action. This is a project where, which I was involved in with the electronic musician Aphex Twin, who wanted to remote control an orchestra, which is possibly an offensive suggestion to some people in this room. Kind of just with his MIDI fader bank, get all of the musicians in the orchestra to be dynamically responding to these actions via headphones that are telling them what notes they should be playing and so on. And I've done various other projects with networks of interacting computers where we've got synchronized sound, synchronized video and so on. And working with small computational devices that you can kind of embed in different physical forms and interact with in different ways. So just a quick example of that. So this project is an active project at the moment, which involves being able to deploy code very quickly onto a device such as the eggs that I just showed. And this is an example of a performance at the NIME New Interfaces for Musical Expression concert, where the entire premise of the performance is that these eggs are just being passed around the audience, and turning the audience in on itself, making that kind of attention via physical interactive devices part of the musical experience. So this is something we're just starting to experiment with, and mostly my interest is in really the bare bones technology, how we actually just achieve creating stuff when, say, you want to do a performance across 15 devices, or maybe you have 15 devices but then you get some more money and so that scales up to 100. How do you make these performances adaptive? How do you understand what they're going to sound like when you don't actually have the context in which you're performing them, and so on? And this is a common thing that people are thinking about in the context of computer music a lot. So it totally connects with what I've been talking about earlier about generative music, because there's essentially a common theme of adaptive systems, designing something that can scale, that you can easily deploy in different contexts and so on. So it has a common theme, and lots of people are developing a practice around that. In the same conference that I just showed the video from, Anderson et al. Just summarized this process based on their own observations in a very simple way. People are taking a composition, decomposing it, pulling apart its core elements, recomposing it, in other words, wiring it together into a behavioral system. So this finally kind of ties back into that theme of behavioral objects. How do you take the raw elements of your composition and wire those together into a dynamic, flexible way? That's the recomposition, and then the recreation is actually being done by a system. So you step back at that stage, and it's the interaction between participants, or the interaction between the software elements themselves, that lead to the actual tangible musical outcome that you see. So the research direction that I'm pursuing now in light of that is basically these two areas of development in how we build these systems. One is adaptation. How do you build systems that are scalable, that are easily composed in such a way that you can recompose them, and that there are sensible rules and kind of compositional practices for doing that. And the other is simulation. Just simply put, how do you prepare that kind of work if it's going to be in a public art context, in an outdoors space, in strange acoustic constraints and so on. So these are two questions that I'm now very, very much focused on looking at and taking an HCI approach to. So I've gone slightly over, but I am at my last slide. So just to summarize that kind of barrage of different themes, I cutting throughout all of this, the notion of software as behavior and developing a multi-scale theory of interaction that helps us to understand working with software as behavior, I think is still a key challenge in this area of practice. Programming is still the best way to give behavior to a computer, going back to the genie metaphor, but it needn't be, because we are constantly moving in that sense, and with natural language recognition that might become a very rapidly changing field where that bar for being able to design software in a machine drops radically. So another point is to emphasize the really great importance of interaction design in all of these areas. So I think it's fair to say that often that's been ignored, and we've taken a kind of very narrow focused approach to building, say, an autonomous system, but not recognizing how that's embedded in a network of behavior and so on. So we're looking at music increasingly occurring in automated contexts across different scales, so across the scale of an entire city or down to a very individual personalized scale. So the multi-scale kind of nature of music as we start to use software more for the production of music. And the final thing I'm kind of banging a drum about at the moment is the importance of developing core software infrastructure. So all of these projects that I'm talking about require a great deal of work, kind of background work, just to get to the point where you're doing the research project and so on. And we're massively helped by some of the tools and technologies that have been made available. For example, I mentioned Max, which came out of URCAM, which came out of a research context. So it came out of a context where people were trying to understand how to make creative production in software easier. And my closing point, I think, would be that I think that's something that we could do more in Australia. We could kind of get that basic infrastructure development happening, which is of benefit to everyone at every level on that scale. So there you go. Thank you very much.
Thank you very much, Ollie. We've got about 10 minutes available for questions, if anyone from the audience would like to ask a question.
Can we play a bit of music whilst the Q&A is going on, please?
Can I? Any requests?
No.
I can try to. I'll go,
Well, I think it'd need to be sort of responding to your voice, perhaps, and then transforming it.
Not ready for that. Maybe so I can focus on the questions. In a second, I'll put something on. Yeah.
Some of what you were showing, I didn't get the connections between everything, but are you saying that you can take a picture and then from that sort of compose some music through it?
I'm not sure which.
You know, you were showing that screen that had all the different images on it.
No, that was just by analogy. So that's existing work in image. So one of the I mean, the very different nature of still images to music makes for very different interaction affordances. Yeah. So, for example, we have systems where we can iteratively evolve music, but of course we have to stop and we have to listen to the music. If you're trying to do that on the scale of entire composition, then that's kind of implausible. Whereas a lot of the success in that field has happened with still images, which have a completely different immediacy. So applying these kind of basic creative technology principles to different domains can work in extremely different ways.
The back there?
Yeah. So when you're talking about designing your systems, for example, when it's just between you and an instrumentalist, and you were talking about some of the principles you'd use to guide those systems, so the ones such as shadowing or coupling, I mean, it's easy to see how you could implement that into an algorithm just based on the acoustic signal. But you mentioned the more cognitive one of negotiation. So maybe without getting too technical about any algorithms, how would you actually exercise something like that? And how would you apply that then to larger projects that span, landscapes and cities?
Well, that's what a huge amount of the effort in the wider sphere of computational creativity is all about. It's basically about getting systems that have an awareness of what it is they're creating. So they close the loop of evaluation is the thing that we talk about. And there's actually there's a difference of opinion in the field about, I mean, everyone agrees that that's great, that's an amazing thing to do, but there's a bit more disagreement about, firstly, what the right path is to getting to that kind of stage of technical sophistication, and secondly, like while you're on the way, whether you're doing it properly, because it's very easy to trivialize that kind of process. You can build a system that feeds back on itself and has some model of aesthetics or preference, but you might not do that very well, and you don't necessarily have a grounding in how to evaluate that once you close that loop. So the kinds of things people are doing are, trying to compare human evaluations with how the machine understands it. We have year on year, we have great progress in terms of the low-level analysis. We can understand harmonic structure, and we can detect beats, and higher-level long-term structure of systems. It's still a pretty hard problem to then kind of really piece together all of this stuff into something that does the whole caboodle. So I don't try at this stage, and I think I see enough of the interesting emerging technologies coming about that I'd like to try. And like I say, people do it. They program in by hand psychological tendencies that their systems have, and so on, and that's of interest. But it's a far cry from that full kind of closed loop.
Yeah, pretty much just following on from that point. There's a perspective in cognitive musicology which kind of follows on from cognitive linguistics around how we understand what we hear in music, what we listen to music as based on patterns of physical experience, motion, verticality, rising melodies, falling melodies, those sorts of things. In an improvisational context like that, I know we know each other, and I've actually played with your system and a couple of others. One thing that struck me every time I've played with a computer system is that it's so different from improvising with another human being, because you do react cognitively to what they play based on, I think, patterns of physical experience that other player is sharing with you. And when you then translate that into a technical session in which you're playing with a computer, somehow all of that is lost, and so the musician is left with having to almost relearn or learn new ways of interacting with the machine system.
Yeah, or take a more kind of primitive approach. Yeah.
Perspective. And I wonder if you've got any comments about that, or do musicians need to develop a new cognitive function to play with machines?
Well, that's kind of what I referred to earlier, is the sort of sense that there's a subgenre of musicians performing with machines where we stepped away from thinking about this ambitious goal of modelling a human in a machine, and by doing that you create a kind of more tractable context in which you can still ask questions like how autonomous did that system seem to be, although those questions are very hard to extract from humans because those are always our reference points. But I think over time the language of thinking about interacting with a machine can be pulled apart from the language of interacting with a person, and that's a kind of slightly like a cultural shift. Yeah.
Treated as a separate.
Yeah, but I mean, behind all of this stuff is things like theory of mind, where you're modelling what the other person is thinking, and they're also modelling what you're thinking, and that goes sort of 2 or 3 levels deep. So you're thinking about what they're thinking about what you're thinking, and so on, and a whole load of stuff about expectation. And people in music information retrieval are doing wonderful things in terms of modelling expectation, and obviously that provides a really interesting framework for being able to say. So I mean, expectation is quite a simple thing. It's just basically how, in the simplest case, is like you've heard 5 notes. What's the likelihood of the next note being a C or whatever? But that can say a huge amount about how you might approach a slightly more cognitively high-level musical interaction. And like I say, I don't really attempt to do those kinds of things in the work I'm doing, but there is a great body of literature that's feeding into musical metacreation in that way.
Okay, we have time for one more question.
Yeah. Could you, might you not run into copyright problems in decomposing and recomposing somebody else's music?
So when I was referring to that, it was actually the composers themselves choosing to take their composition and provide it in a dynamic, interactive way. You certainly might run into copyright issues, as I mentioned, if you had a machine that learnt, but you weren't paying close enough attention and you actually let that machine overlearn some piece of music to the point where they spewed out an exact replica of something that was in their data set. And I'm sure we will see instances of that coming about.
Well, copyright, it's certainly around us all the time, and even in this area. And I feel we've only scratched the surface today, but thank you, Ollie, for giving such a lucid exposition of the topic. And I think that there's so much more for us to learn, and this area is just going to keep growing and growing. And there's so many amazing things. Even this thing about the interaction design and about how people are going to interact with this as listeners and performers, and I'm very pleased to see you'll be at the forefront of it. Can you please thank Ollie for his talk?
Thanks, Stefan.
Please.